Hey everyone, I'm gonna start this waves lecture. First off, I want to say where you can find my packet. This normally would have been um, where this normally would have been printed for you. So this is where you would find it. You click on this link under the schedule, takes you to the packet. Um, so we're gonna get started on this lecture on page 3. This is under the assumption that you've done the videos that are found on the website, these 2 videos. A lot of this is going to be a repeat of what you already know. So this is how I normally do things. As you know, I make you guys watch a video or do a reading, and then I lecture on it after. This way you get the information like 2 or 3 times, which hopefully sticks with you better. Okay, so I'm going to use this, and we're going to talk about waves. So the first thing you need to understand is what a mechanical wave is. And I would love to call on you guys to tell me what this is, because I'm sure you know about it since you've read it. A mechanical wave is a wave that requires a medium to move through. And by medium, that basically just means stuff. And that stuff can be a lot of times the atmosphere, like air, like sound waves travel through air. You can hear underwater. So in that case, water would be a medium in that case. In class, we would normally do a slinky, and we would shake the slinky so the waves would travel through the slinky. At sporting events, sometimes you see like a human wave when people do the wave. So in that case, the wave is traveling through humans. And basically what a wave is, it's a way to transfer energy from one particle to another particle. So for the human wave, when each person puts their hand up there, they're actually like the particle itself. And in a wave, that stuff is all connected, like the humans are connected. So if you were doing a vibration, that vibration would be moved on to the next person. So it's like a domino effect. So it's kind of hard to explain. If you were in class right now, I would have you guys demo this. But basically what you need to know is that a mechanical wave requires a medium. So the first type of wave is a longitudinal wave. And what this means is particles move back and forth parallel to the wave's motion itself. Okay, so I'm going to show you what that would look like. So this is my longitudinal wave, and I want you to focus, try to keep your eye on just one particle. Okay, so I like this particle. I'm not sure if you can see what I circled. But you'll notice if you keep your eye on just one particle, it's not like it's moving from here all the way to here. That's not what's happening. Instead, the particle is just moving back and forth in its area, and it's causing other particles to move because it's moving. Okay? So, like I said before, it's kind of like a domino effect. Because this one is vibrating back and forth, it's causing the next thing, it's causing the next thing, it's causing the next thing, and it's just like a chain reaction of particles vibrating back and forth in its own local area. So the wave itself is moving from left to right. And if you notice, the particles are also moving from left to right. So because the particles are moving from left to right and the wave itself is moving from left to right, those 2 directions are parallel, which means it's a longitudinal wave. One way that's good to memorize this is parallel has a lot of L's in it, and longitudinal starts with an L. So that's one way to memorize this. You'll have to know the difference between the different types of waves. And longitudinal is, with the L's, is one way to remember that. Okay. So okay, so a transverse wave is, let me actually just show it to you first before I write it down, is, this is very easy to see. You can see if you keep your eye on one particle, you see that it's moving up and down, up and down. So if you look at this particle, it's moving up and down, whereas the wave itself is moving from left to right. So this is the definition of a transverse wave, when the particle movement is perpendicular to the wave motion. Okay, so the particle is perpendicular to the wave. And the way I suggest kids memorize this is the perpendicular sign looks like an upside down T, transverse, perpendicular. Okay, so particles of the medium move back and forth perpendicular to the wave's motion. So this is moving up and down. The wave velocity or the motion is going from left to right. Surface waves are a combination of transverse and longitudinal. So because they're a combination of both of these, they make a circular motion. Or you'll see, okay. So this basically says water waves, and water waves, if you like throw a pebble in water, it would make kind of like a motion like this, which ends up being transverse and longitudinal at the same time. So I'm going to show you some examples of that on these links I have on my website. So if you click on these, you can see them too.
To fly a rocket ship, you need to be an optimist. I'm an astronaut.
Okay, so there's a couple of waves in this. This is a really crazy video. You can watch it on your own time. It's from the 1930s. It's like a music, it's a show of some sort. Okay, this is a transverse wave because these are like these they have in the hand are the particles, and you can see the wave is going from front to back. Okay, there's another wave in this video right here. This is a really good situation to explain because these little paper cards that these women are holding are all connected to each other. So if one person goes up or down, it causes the next person to go up or down. So you see that the wave motion itself is moving from right to left, but each person, the particle is going from up and down, which means this is a transverse wave because those two directions are perpendicular. Okay. And if you go through these videos on your own, you can see the different types of waves. And next to this, I'm going to, maybe after a day or two, I'll put what type of wave it was supposed to be that you were supposed to see. So if you watch these videos, they kind of take you through different types of waves. Okay, so we're going to the next page. I'm going to draw a picture. These are some basic characteristics of a wave. Okay. So we'll start with wavelength. Wavelength is, if you look at this picture right here, it's the length of the wave of one cycle. Okay. So let's say this is where I start the wavelength. When it starts to repeat itself is right over here. So it goes up, passes the center again, goes down, then comes back to the center. So this is one cycle. The length of this is from this point to this point. Okay? So that's a wavelength. So I'm going to just write the length of a wave, and the symbol we use for wavelength looks like an upside down W, like that. And we call that lambda. Okay, and we measure lambda in, just like all lengths, in meters. Okay, a common misconception is thinking that the wavelength is like this length, and that's not true. You don't measure, like you don't take a tape measure and measure this entire thing. It's just the straight across distance from point A to point B. Okay. Okay, amplitude. Amplitude is the height of the wave from equilibrium to the crest or the trough. And we need to explain what these two words mean too. So actually, we should have done that first. And I think you know a lot of this from chemistry and maybe from math, but the crest is the top most point of a transverse wave. So right here is a crest, and right here is a crest. Okay, the trough is the bottom most point of a transverse wave. So this right here is your trough. So equilibrium is the middle area right here. Okay, so when we're talking about amplitude, the amplitude is the height from the wave from equilibrium to the crest. So that means this right here is the amplitude, or this right here is the amplitude. Some people will say, and they're wrong, this is a big misconception, say from top to bottom is amplitude, and that's not right. That would be 2 amplitude, okay? So that's 2 amplitude because it goes from all the way to the top to all the way to the bottom. Okay, so a period, we've talked about period, I think, before. We talked about in circular motion. It's the time it takes for one cycle. And that's measured in seconds. Okay, so it's how long it would take for this point,